December 1944. The Hürtgen Forest, a nightmare of shattered trees, frozen mud, and German positions that swallowed American infantry battalions whole. Company commanders crouched in foxholes, watching their men die while artillery support sat miles behind the lines, unreachable. Conventional communication required field telephone lines strung through combat zones, vulnerable to every shell burst, or runners sprinting through killing fields with handwritten coordinates. But strapped to the back of a single radio man walked a different answer. Trial reports from Fort Monmouth described a portable FM transceiver that could reach artillery batteries directly from the front lines. Commanders expected limited range with unreliable performance in combat conditions. Instead, early field tests showed something extraordinary. A forward observer could call fire missions in 90 seconds from first contact to shells impacting enemy positions. The numbers suggested a fundamental revolution in battlefield coordination, one that would soon face its baptism of fire against entrenched Wehrmacht forces who had never encountered an enemy that could summon artillery faster than they could take cover. The question wasn't whether radio would change warfare. The question was whether American industry could build them fast enough, whether infantrymen could master the technology under fire, and whether the Germans would find a counter before this invisible network tore their defensive doctrine apart. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. January 1943. The War Department, Washington, D.C. After-action reports from North Africa covered conference tables in the Signal Corps planning rooms. Lieutenant Colonel James D. O'Connell spread casualty statistics across the mahogany surface, each page documenting the same lethal pattern. American infantry engaged German positions, called for artillery support, and died waiting for fire that arrived too late, or not at all. The expectation had been straightforward. Field telephones would provide reliable communication between forward observers and artillery batteries. The reality in combat shattered that assumption within hours of first contact. German artillery systematically targeted communication lines. A single 88mm shell could sever cables linking entire battalions to their fire support. Repair crews ventured into no man's land to splice lines, becoming casualties themselves. By the time communications restored, the tactical situation had changed completely. Runners offered the alternative, but speed killed that option. A soldier carrying written coordinates through combat zones required 15 to 30 minutes to reach artillery positions, deliver fire mission data, and allow gun crews to calculate firing solutions. German forces used those minutes to reinforce threatened positions, shift reserves, or simply withdraw before American shells arrived. The statistics were damning. In engagements where American infantry achieved surprise against German positions, artillery support arrived on target in fewer than 40% of instances. When support did arrive, average time from initial contact to first rounds, impacting measured 22 minutes. German doctrine emphasized immediate counterattack against penetrations. 22 minutes gave them multiple opportunities to crush American advances before artillery could intervene. O'Connell's technical assessment identified the core problem with brutal clarity. Current communication methods fail under combat stress. Wire becomes unreliable. Runners are too slow. Infantry dies unsupported. The requirement emerged from that simple calculus. Portable radio equipment capable of reaching artillery batteries directly from frontline positions, ruggedized for combat conditions, simple enough for soldiers to operate under fire. The U.S. Army possessed radio technology, but existing systems failed critical requirements. The SCR-194 and SCR-195 radios served artillery batteries well for battalion-level coordination, but weighed over 100 pounds with their power supplies. Backpack models like the SCR-284 required multiple soldiers to transport and complicated antenna assemblies that took minutes to deploy. None could be carried by a single soldier moving with assault infantry. Frequency modulation offered the technical solution. FM radio, still relatively new in 1943, provided advantages over amplitude modulation that seemed purpose-built for battlefield requirements. FM signals resisted interference from electrical storms, vehicle ignition systems, and enemy jamming attempts. FM transceivers could operate on the move without the careful tuning AM equipment demanded. The technology existed. Engineering a combat-ready portable FM transceiver capable of multi-mile range became the challenge. March 1943, Fort Monmouth, Signal Corps Laboratories. New Jersey engineer Fred Link stood in a laboratory packed with vacuum tubes, oscilloscopes, and prototype radio equipment. His team had 6 months to solve a problem that combined electrical engineering, mechanical design, and battlefield psychology into a single 35-pound package. The technical requirements seemed contradictory. Maximum range of 5 miles with line-of-sight transmission, battery operation for 12 continuous hours, frequency modulation for interference resistance, 18-inch whip antenna that wouldn't catch on vegetation or betray the operator's position, waterproof construction for operation in rain, snow, and stream crossings. Simple controls that exhausted soldiers could operate in darkness or under fire, weight not exceeding what a single soldier could carry alongside personal weapons and combat equipment. Each requirement conflicted with others. Greater range demanded more transmission power, which required larger batteries, which increased weight. Ruggedized construction added bulk. Waterproofing created heat dissipation problems for vacuum tubes, generating substantial thermal output. The antenna length represented a compromise between effective radiation and tactical concealment. Link's team worked through each problem systematically. The transmitter used 5 vacuum tubes in a frequency-modulated oscillator circuit operating between 40 and 48 MHz. This VHF band provided the range required while keeping antenna dimensions practical. The receiver employed 8 tubes in a super heterodyne configuration that provided sensitivity adequate for weak signals at maximum range. Power came from 2 BA-70 batteries, providing 103.5 volts for tube plate supplies, and separate BA-23 batteries for filament heating. Total battery weight reached 14 pounds, nearly half the complete system weight. Engineers calculated that operational duration of 12 hours required batteries of at least this capacity. Reducing battery weight meant reducing operational time, forcing soldiers to carry spare batteries, negating any weight savings. The waterproofing challenge demanded innovative solutions. Conventional methods sealed components in rubber gaskets and protective housings, but added excessive weight. Link's team developed a treatment process that impregnated circuit boards and components with moisture-resistant compounds, creating protection without heavy external casings. The handset and controls received rubber seals that allowed operation with wet hands while keeping water away from electrical connections. Field testing began in April 1943 at Fort Monmouth's proving grounds. Engineers simulated combat conditions as closely as peacetime ranges allowed. Test operators carried prototype transceivers through obstacle courses, forded streams, crawled through mud, and transmitted from prone positions under simulated artillery fire. Each test revealed weaknesses requiring redesign. Antenna mount broke during rough handling. Engineers reinforced it with steel brackets. The frequency selector proved difficult to adjust with cold fingers. Designers enlarged the control knob and added raised markings readable by touch. The handset cord tangled in equipment. Technicians developed a coiled cable that retracted when released. Each modification added ounces that accumulated into pounds. Each pound subtracted from mobility and endurance. By June 1943, the SCR-300 had reached production configuration. Final specifications documented a complete system: transceiver unit with antenna, handset, batteries, carrying case with shoulder straps, spare parts kit, and instruction manual. Total weight: 32 pounds basic configuration, 38 pounds with full battery load and accessories. Range: up to 5 miles under ideal conditions, reliably 2 to 3 miles in typical terrain. The contrast with existing equipment was stark. An SCR-284 required 3 soldiers to transport and operate. The SCR-300 needed 1. The SCR-284 took 15 minutes to deploy its antenna system and establish communications. The SCR-300 was ready to transmit within seconds of removing it from its case. The older radio required careful tuning and adjustment. The new transceiver used preset crystal-controlled channels that eliminated tuning procedures. August 1943, Camp Polk, Louisiana, the 90th Infantry Division, received the first production SCR-300 radios for field evaluation during training exercises. Lieutenant Robert Chen, forward observer with the 343rd Field Artillery Battalion, attended the familiarization course with skepticism earned through 2 years watching communication equipment fail under field conditions. The instructor, a Signal Corps sergeant fresh from Fort Monmouth, demonstrated the radio with a confidence that Chen found either admirable or naive. Range to your artillery batteries, 3 miles typical. Setup time, from receiving the radio to transmitting, under 60 seconds. Operation, simple as a telephone. Chen had heard similar promises about the SCR-284. That radio had proven temperamental, its range unpredictable, its antenna assembly a tactical liability that drew enemy fire. The SCR-300 looked more practical, certainly more portable, but battlefield conditions destroyed optimistic laboratory performance with reliable cruelty. The familiarization course covered basic operation in 4 hours. Students learned to insert batteries, extend the antenna, select frequencies, and transmit using proper radio procedure. The simplicity was genuine. Turn the power switch, rotate frequency selector to assigned channel, press transmit button, speak clearly into handset, release button to receive. Even soldiers with no radio experience grasped the basics within minutes. The training exercise that followed tested the system under field conditions. Infantry companies advanced across swampy terrain toward mock enemy positions while carrying SCR-300 radios. Forward observers accompanied assault platoons, maintaining continuous communication with artillery batteries positioned 3 miles behind the line of departure. Chen moved with a rifle company through pine forest and marshland. The radio operator, Private Michael Torres, kept pace despite the additional 38 pounds on his back. When the company encountered simulated enemy resistance, Chen grabbed the handset and called a fire mission exactly as he would during combat. Fire mission, grid 847293, enemy infantry in tree line, will adjust. The response came back immediately from the fire direction center. Shot out. 30 seconds later, splash. In a real engagement, high explosive shells would be impacting the target. Total elapsed time from spotting the enemy to simulated artillery fire, 90 seconds. The contrast with previous methods was profound. With field telephones, establishing communication required finding a working line, assuming one existed. With runners, the same. Mission would have taken 20 minutes minimum. The SCR-300 collapsed that timeline to under 2 minutes, a compression ratio that fundamentally altered tactical possibilities. Not every test succeeded perfectly. Radios failed when batteries ran low. Transmission quality degraded in deep valleys where terrain blocked line-of-sight paths. Operators occasionally selected wrong frequencies or garbled transmission procedures under stress. But the success rate exceeded 85% across multiple exercises, a reliability figure that convinced skeptical artillery officers. Chen's after-action report documented what the statistics meant in human terms. Previous doctrine required forward observers to position themselves with clear lines of sight to both enemy positions and friendly artillery, maintaining visual or wire communication with gun batteries. This forced observers into exposed locations and limited mobility. The SCR-300 permits observers to advance with assault infantry, maintaining continuous communication from any location with adequate transmission path. Infantry gains responsive fire support during the most critical phases of combat, when enemy resistance is strongest and friendly casualties highest. November 1943, Production and Doctrine Development, Galvin Manufacturing Corporation's production lines in Chicago assembled SCR-300 radios at accelerating rates. Initial contracts called for 1,000 units per month. By late 1943, production reached 3,000 monthly, as procurement officers revised requirements upward based on training reports from units awaiting deployment to Europe. The manufacturing process revealed unexpected challenges. Vacuum tubes required careful handling and quality testing. Each tube underwent individual verification before installation. Battery production couldn't initially keep pace with transceiver manufacturing, creating shortages that limited fielding rates. Waterproofing treatments required precise application and curing times that slowed assembly. Workers on the production floor understood their work's importance through letters from soldiers training with early production models. One letter, posted on the factory bulletin board, came from a sergeant at Fort Benning. "This radio keeps working when everything else fails. It's going to save lives. Build them as fast as you can." Parallel to manufacturing expansion, doctrine development proceeded at the Infantry School and Artillery School. Officers studied how portable radio communications would change tactical employment of forward observers, artillery coordination, and infantry-artillery integration. Traditional doctrine positioned forward observers with company commanders, connected to artillery batteries through field telephone networks maintained by signal platoons. The observer remained relatively static, calling fire from positions offering observation of enemy-held terrain. When telephone lines failed, the observer lost effectiveness until communications restored. The new doctrine emphasized mobility and integration. Forward observers would accompany infantry platoons during assaults, maintaining continuous radio contact with fire direction centers. Artillery batteries would remain on alert status, ready to fire within seconds of receiving coordinates. The combination promised to transform artillery from preparatory fire delivered before assaults into responsive fire available throughout combat operations. Fire mission procedures required standardization to maximize speed. The Artillery School published field manuals detailing exact terminology, coordinate formats, and communication protocols. Every forward observer would use identical procedures, allowing any artillery battery to respond immediately, without confusion or requests for clarification. A typical fire mission followed this sequence: observer, fire mission, fire direction center, fire mission, over, observer, grid 748392, enemy troops in open, will adjust, FDC, grid 748392, enemy troops in open, will adjust, out. The FDC calculated firing data and transmitted commands to gun crews. Within 30 seconds, guns fired. The observer watched shell impact and transmitted corrections. Add 100, write 50. The FDC adjusted, guns fired again. The entire process, from initial contact to shells on target, reliably completed within 90 seconds. The psychological implications received less formal analysis, but generated intense discussion among officers who understood combat's human dimensions. An enemy who learned that American infantry could summon artillery within 90 seconds would face impossible choices: maintain positions and endure accurate fire, withdraw immediately and surrender ground without fighting, attempt to overrun American positions before artillery arrived, accepting casualties during the approach. None offered good options. January 1944. Final training before deployment. The 4th Infantry Division prepared for deployment to England and eventual participation in the Normandy invasion. Lieutenant Thomas Hawkins, forward observer with the 20th Field Artillery Battalion, conducted the final radio training for his section before embarkation. 6 soldiers attended the session, each training to operate the SCR-300 inches combat. Hawkins emphasized principles learned during months of field exercises. The radio works if you work with it. Keep batteries dry, carry spares, extend the antenna fully, use proper procedure every transmission. The Germans will be listening. Clear, brief, accurate. The gun crews trust your coordinates. Infantry trusts the guns. We're the link. If we fail, soldiers die. The training covered scenarios that peacetime exercises couldn't fully simulate: operating under artillery fire while calling corrections, maintaining communication while moving through urban terrain, establishing contact after radio damage. Each scenario emphasized that the technology enabled new tactics only if operators remained proficient under maximum stress. Private James Morrison, radio operator assigned to Hawkins's observer team, had carried the SCR-300 through countless training exercises. "It's heavy, sir, but I've carried worse. And knowing artillery is just 90 seconds away makes every pound worth it." That calculation, pounds of equipment versus seconds of response time, defined the SCR-300's value proposition. The radio weighed 38 pounds fully loaded. A soldier carrying it sacrificed mobility and endurance. But that single soldier enabled the entire rifle company to access artillery fire that could destroy enemy positions, suppress counterattacks, and break defensive lines. The trade was brutally favorable. As the division prepared to board transport ships, Hawkins inventoried his equipment one final time. SCR-300 transceiver. Spare batteries. Maps with artillery battery positions marked. Signal operating instructions with frequencies and call signs. Binoculars for observing fire. Personal, weapons and combat equipment. He was ready to test whether 90 seconds would prove fast enough when German positions started shooting back. The technology was proven. The doctrine was established. The training was complete. What remained unknown was whether American soldiers could execute this new form of warfare against a determined enemy who had spent 4 years perfecting defensive tactics. The Hürtgen Forest, the hedgerows of Normandy, and the frozen fields of the Ardennes would provide the answers. Men would live or die based on whether radio waves could truly outpace bullets and shells in the brutal calculus of infantry combat. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The 6th of June, 1944, Omaha Beach. Normandy dawn broke over the English Channel as landing craft pushed through rough seas toward the French coast. Lieutenant Thomas Hawkins crouched in the bow of his Higgins boat, SCR-300 radio, strapped to Private Morrison's back beside him. The 4th Infantry Division had been redirected to Utah Beach, but forward observers from the 1st and 29th Infantry Divisions carried identical radios toward Omaha Beach, where German defenses would provide the SCR-300's first test under fire. Captain David Grant, forward observer with the 116th Infantry Regiment, waded through chest-deep water as German machine guns raked the beach. His radio operator, Corporal Stephen Walsh, struggled forward with the SCR-300, held above the waves. They reached the seawall and collapsed behind the minimal cover, surrounded by wounded soldiers and destroyed equipment. Grant's mission was clear, but seemed impossible under current conditions. Establish communication with artillery batteries aboard destroyers offshore. Direct naval gunfire against German bunkers that were systematically destroying every American attempt to advance off the beach. Without artillery support, the landing would fail. The entire invasion could collapse on this single beach if naval guns couldn't suppress those bunkers. Walsh extended the antenna with shaking hands. Salt water dripped from the transceiver case, but the waterproofing held. Grant grabbed the handset and keyed the transmit button. Static crackled, then cleared. Fire mission. Bunker position. Grid 487392. Troops pinned down. Urgent. Over. The response came immediately from USS Frankfurt, a destroyer positioned 3 miles offshore. Frankfurt. Shot out. Observe. 30 seconds later, a 5-inch shell screamed overhead and impacted 50 meters beyond the bunker. Grant watched the explosion, calculated correction, transmitted. Drop 50. Fire for effect. The destroyer's guns opened up, pouring shells into the German position. The bunker's firing slits went dark. Machine gun fire ceased. American soldiers rose from cover and advanced. Total elapsed time from Grant's first transmission to suppressed bunker: 2 minutes, including the adjustment round. With conventional communication methods, If communication could be established at all from a contested beach, the process would have taken 30 minutes, minimum. Grant moved forward with the infantry, Walsh following with the radio. They called fire on 3 more positions during the next hour. Each mission followed identical procedure: spot target, transmit coordinates, observe impact, adjust, fire for effect. The rhythm became automatic despite the chaos surrounding them. By noon, forward observers across Omaha Beach had called over 40 fire missions using SCR-300 radios. Naval gunfire destroyed or suppressed bunkers, trench systems, and artillery positions that had nearly stopped the invasion. After-action reports would credit the radio-coordinated naval gunfire with enabling infantry to break through German beach defences during the critical first hours. The expectation among German commanders had been straightforward. American forces would require hours to establish communication networks after landing. Infantry would advance unsupported by artillery. Defenders would use that window to destroy landing forces before they consolidated. The reality shattered that assumption within minutes. American infantry brought their artillery with them, invisible and immediate, arriving through radio waves faster than German troops could respond. The 10th of June, 1944. Hedgerow country. Normandy interior. The 90th Infantry Division pushed inland from Utah Beach into the bocage, the infamous hedgerow country where every field became a fortress and every hedge concealed German positions. Lieutenant Robert Chen, now forward observer with a frontline rifle company, discovered how the SCR-300 transformed small unit tactics in this nightmare terrain. Traditional artillery support required forward observers to position themselves with clear sight lines to both enemy positions and friendly artillery batteries. The hedgerows made this impossible. Visibility extended perhaps 50 meters before another hedge blocked the view. Conventional doctrine would place observers in static positions, directing fire based on map coordinates and infantry reports. The delay between contact and fire support would cost lives in terrain where ambush range measured in meters. Chen adopted different tactics. He accompanied the lead platoon, radio operator Private Torres staying within arm's reach. When the platoon encountered German positions in a hedgerow, Chen called fire immediately, without withdrawing to observation posts or consulting elaborate fire plans. The first such engagement occurred at a crossroads where German infantry had prepared defensive positions in the thick vegetation. The American platoon came under machine gun fire at 30 meters range. Conventional tactics required the infantry to fix the enemy, call for support through chain of command, wait for artillery to respond. Casualties accumulated during those minutes of waiting. Chen's approach eliminated the waiting. He dropped prone, grabbed the handset from Torres, and transmitted while bullets snapped overhead. Fire mission. Grid 582947. Enemy infantry, hedgerow position, danger close, will adjust. The fire direction center 3 miles behind the lines received his transmission instantly. Guns were calculated. Within 60 seconds, shells arced overhead. The first round landed 40 meters beyond the German position. Chen observed the impact through the hedge gaps, calculated correction, transmitted, drop 40, fire for effect. The battery salvoed 6 rounds that saturated the hedgerow where German troops had been positioned. When the explosions ceased, the machine gun was silent. The American platoon advanced, finding destroyed positions and wounded Germans who had survived the barrage but lost all will to continue fighting. This engagement pattern repeated itself dozens of times daily across the Normandy front. Infantry encountered resistance. Forward observers called fire within seconds. Artillery responded in under 2 minutes. German positions were suppressed or destroyed. Infantry advanced. The tempo was relentless and demoralizing for defenders who faced an enemy that seemed omniscient and infinitely patient, willing to call artillery on any position showing resistance. German after-action reports began documenting a problem they couldn't solve. Defensive positions that should have held American forces for hours were being neutralized within minutes. American artillery fire arrived with suspicious speed and accuracy. German officers suspected American forces had developed new observation techniques or possessed intelligence about every defensive position. The simpler truth that American infantry carried radios connecting them directly to artillery seemed too revolutionary to credit. July 1944. German Defensive Analysis. Normandy Sector, Oberst Wilhelm Hoffmann, Operations Officer with the 352nd Infantry Division, studied casualty reports and tactical summaries from subordinate units with growing alarm. His division had suffered 60% casualties during 3 weeks of continuous combat. The Americans were destroying German positions with artillery fire of unprecedented accuracy and speed. Hoffmann's analysis identified the pattern even if he didn't fully understand the mechanism. American infantry patrols operated with unusual confidence, advancing boldly into areas that should have been swept by pre-registered German defensive fires. When German troops engaged these patrols, American artillery responded within minutes with accurate fire on German positions. The Americans somehow possessed the ability to summon fire support faster than German doctrine anticipated. Interrogation of American prisoners provided crucial insight. One captured forward observer, a lieutenant from the 4th Infantry Division, explained the SCR-300 system under questioning. He described portable radios that allowed direct communication with artillery batteries from frontline positions. He estimated response time at 90 seconds from initial contact to shells on target. Hoffmann's initial reaction was disbelief. 90 seconds? His own artillery units required minimum 10 minutes from receiving fire mission requests to delivering fire, and that assumed functioning telephone networks. 15 to 20 minutes was typical. The American claim seemed like propaganda or exaggeration designed to lower German morale, but the tactical evidence supported the prisoners' statements. Hoffmann compiled reports from battalion commanders describing encounters where American artillery arrived with impossible speed. One report detailed a company-strength counterattack that came under artillery fire within 2 minutes of engaging American infantry. Another described a battalion assembly area struck by artillery before the counterattack even began, suggesting Americans could predict German movements or observe German rear areas continuously. The problem for German forces was compounded by their own communication limitations. German doctrine relied on field telephone networks for tactical communication. Radio equipment existed but was generally restricted to battalion level and above. Company and platoon commanders communicated through telephone lines or runners. When artillery severed those lines, German units operated in isolation until repairs could be made. Hoffmann recognized the asymmetry. American forces possessed communication networks that functioned under fire. German networks degraded rapidly during combat. The Americans could coordinate combined arms operations continuously throughout engagements. German coordination broke down after the first artillery barrage. The American system proved resilient and adaptive. The German system was fragile and rigid. Countermeasures were limited and unsatisfying. German signals intelligence units attempted to locate American radio transmissions, but the SCR-300's VHF frequencies and brief transmission times made direction finding difficult. Jamming proved ineffective because American radios used frequency modulation that resisted interference. The Americans also employed frequency changes and proper signal security, limiting intelligence value even when transmissions were intercepted. The most effective German response was immediate withdrawal when American artillery fire began. Units learned to recognize the signs of an imminent barrage, American infantry taking cover, observation aircraft overhead, the distinctive whistle of incoming rounds, and evacuate positions immediately. This tactic preserved lives but surrendered ground without fighting, exactly what American commanders wanted. Hoffmann's final assessment, forwarded to division and corps headquarters, painted a grim picture. American portable radio communications provide decisive advantage in coordination speed. Their infantry can summon artillery support faster than our forces can respond. Defensive positions become untenable under concentrated fire. Our counterattack doctrine assumes we can mass forces before American artillery responds. This assumption no longer holds. New tactics must be developed, or casualties will remain unsustainable. No satisfactory new tactics emerged. German forces lacked the industrial capacity to produce portable radio equipment matching American capabilities. Even if equipment existed, training thousands of soldiers to operate radios while maintaining combat effectiveness required time Germany didn't possess. The Wehrmacht would fight the remainder of the war at a fundamental communications disadvantage that multiplied every other deficit they faced. September 1944, the Hürtgen Forest. The Hürtgen Forest became a meat grinder where American advantages in firepower and technology met German defensive expertise in terrain that nullified mobility and observation. Dense woods, steep ravines, and prepared bunker systems created conditions where the SCR-300 faced its greatest challenge. Staff Sergeant William Bradford, radio operator with the 28th Infantry Division's forward observer teams, learned that even revolutionary technology had limits. The forest canopy blocked line-of-sight transmission paths essential for VHF radio. Valleys and ridges created dead zones where no signal could penetrate. Wet weather degraded battery performance. The radio that worked flawlessly in open terrain struggled in the Hürtgen. Bradford and his observer team developed adaptive techniques through brutal trial and error. They identified hilltops and ridges where transmission quality improved. They cached spare batteries in waterproof containers at key positions. They established relay stations where radio operators positioned themselves at high points, receiving transmissions from forward observers and retransmitting to artillery batteries beyond the forest. The relay system worked but added complexity and delay. A forward observer calling fire from deep in the forest transmitted to a relay station on a ridge, which retransmitted to the fire direction center. Response time increased from 90 seconds to 3 or 4 minutes, still faster than alternatives, but the margin had narrowed. German forces exploited every second of that delay. They learned that American artillery required brief windows between detection and suppression. Aggressive infantry assaults could close with American positions before artillery arrived if launched immediately upon contact. Machine gun positions fired short bursts, then displaced to alternate positions before return fire could be directed accurately. The Germans were adapting, finding tactics that minimized American advantages. One engagement illustrated both the SCR-300's continuing value and its limitations under extreme conditions. Bradford's observer team accompanied a rifle company assaulting a German bunker complex. When the company came under fire, the lieutenant called for artillery support. Bradford transmitted the fire mission, but received no response. The forest terrain blocked his signal. Bradford grabbed the radio and ran toward higher ground while bullets snapped through the trees around him. He reached a small rise, extended the antenna, transmitted again. This time the fire direction center acknowledged. Fire mission. Grid 6844729. Enemy bunkers. Urgent. The artillery response came in under 2 minutes, suppressing German positions long enough for American infantry to close and destroy the bunkers with satchel charges. After the engagement, Bradford's lieutenant wrote in his personal diary, "The radio saved us again today, but Bradford nearly got killed making it work. This forest is hell for communications. We're fighting blind half the time. The radio helps when it works, but the Germans know its limitations now. They're learning to exploit terrain that blocks our signals." December 1944. The Ardennes Battle of the Bulge German forces launched their final major offensive on the 16th of December 1944, striking through the Ardennes with the goal of splitting Allied armies and capturing the port of Antwerp. The initial assault achieved tactical surprise, overrunning American positions and creating chaos throughout the front. The SCR-300 proved invaluable during the confused fighting that followed. American units found themselves surrounded, communications with higher headquarters severed, normal chain of command disrupted. In these conditions, portable radio equipment provided the only reliable communication, enabling isolated units to coordinate defense and call for artillery support. Lieutenant James Morrison, formerly radio operator under Lieutenant Hawkins, now served as forward observer with the 101st Airborne Division defending Bastogne. When German forces encircled the town, cutting road connections and telephone lines, the SCR-300 became the primary link to artillery batteries inside the perimeter and to friendly forces attempting relief from outside. Morrison operated from the town's outskirts, directing fire against German armor and infantry probing American defenses. The radio worked continuously, despite below-freezing temperatures that drained batteries faster than normal. Morrison rotated through 6 batteries during the first day, keeping the radio operational through constant battery changes. German forces made capturing or destroying American radio equipment a priority target. They recognized that American units without radio lost much of their combat effectiveness. German infantry receiving orders to capture positions were specifically instructed to target soldiers carrying radio equipment. The distinctive whip antenna made radio operators easily identifiable targets. Morrison learned to keep the antenna collapsed when not actively transmitting, extending it only when calling fire missions. He positioned himself in covered locations that offered transmission paths without exposing him to direct fire. These precautions couldn't eliminate risk entirely. During one fire mission, a German sniper wounded Morrison in the shoulder while he stood calling corrections. He completed the mission before seeking medical treatment, maintaining contact until artillery suppressed the German position threatening his infantry company. The siege of Bastogne demonstrated the SCR-300's strategic value beyond tactical fire support. When weather cleared enough for aerial resupply, forward air controllers used SCR-300 radios to communicate with transport aircraft, directing supply drops to specific locations within the perimeter. The same radios coordinated close air support when fighter bombers arrived to attack German forces surrounding the town. Medical evacuation requests, intelligence reports, and command communications all flowed through portable radios that remained functional when every other communication system had failed. Relief forces breaking through to Bastogne relied on SCR-300 radios for final coordination. Forward observers with the lead elements communicated directly with defenders inside the perimeter, ensuring relief columns advanced toward friendly positions without confusion. The link-up on December 26 succeeded partly because radio communications prevented the friendly fire incidents that plagued earlier relief operations in other sectors. February 1945. Crossing the Ruhr River, American forces prepared to cross the Ruhr River and advance into Germany's industrial heartland. The operation required intricate coordination between infantry assault boats, supporting armor, artillery, and air support. The SCR-300 became the central nervous system, enabling that coordination under combat conditions. Captain Robert Chen, now commanding a forward observer section with the 9th Infantry Division, briefed his teams on communication requirements for the river crossing. "We'll have observers in the assault boats, on the near bank, supporting follow-on waves and forward of the river calling fire on German positions. Every observer maintains continuous communication. Artillery will be firing danger close missions over our own troops. Accuracy is everything. Clear transmissions, exact coordinates, double-check every fire mission." The crossing began before dawn, on the 23rd of February 1945. Chen crossed in the first wave, SCR-300 operator beside him in the assault boat. German forces held the far bank in strength, prepared defensive positions commanding every likely crossing site. The moment American boats entered the water, German artillery and machine guns opened fire. Chen transmitted continuously during the crossing, calling fire missions against German positions while trying to avoid swamping the boat with radio equipment. Fire mission. Grid 793284. Machine gun position, near bank, danger close. The artillery responded within seconds. Shells impacted the German position. The machine gun went silent. The boat reached the far bank. Establishing the bridgehead consumed 12 hours of continuous combat. Chen and other forward observers called over 200 fire missions during that period, averaging one mission every 3 minutes. Artillery fire suppressed German counterattacks, destroyed observation posts, neutralized artillery batteries, and supported infantry advances. The coordination achieved through portable radio communications enabled the division to establish a secure bridgehead with casualties far below planning estimates. German forces attempted to disrupt American communications through artillery fire targeted at suspected radio positions, but the shoot-and-scoot tactics forward observers had perfected made this countermeasure ineffective. Observers transmitted, moved immediately to new positions, transmitted again from different locations. German artillery fired at positions observers had vacated minutes earlier. By evening, American forces held a bridgehead 2 miles deep and 4 miles wide. Engineers constructed pontoon bridges under protection of artillery fire, directed by forward observers operating from the far bank. The crossing succeeded because American infantry could call artillery support instantly throughout the operation, maintaining continuous fire support that gave German defenders no respite and no opportunity to mount effective counterattacks. March 1945. The Rhine crossings and final campaigns. The assault across the Rhine River in March 1945 represented the culmination of American artillery-infantry coordination perfected over 11 months of combat. Forward observers accompanied assault troops across the river in the first boats, calling fire missions before setting foot on German soil. Artillery fire preceded infantry by seconds rather than minutes, walking forward ahead of advancing troops in a continuous barrage that shattered German defensive positions. The scale of coordination achieved through radio communications would have seemed impossible in 1943. Single fire missions now involved multiple artillery battalions, firing time-on-target salvos, where hundreds of shells arrived simultaneously on German positions. Forward observers directed not only conventional artillery but also fighter-bomber strikes, bringing air power to bear within minutes of identifying targets. German prisoners captured during the Rhine crossings expressed a common theme during interrogation. They described facing an enemy who seemed to possess unlimited artillery and perfect knowledge of German positions. One German officer stated, "We could not maintain any position under American observation. Within 2 minutes, artillery fire would destroy it. We could not mass forces for counterattack without immediate American artillery response. We could not communicate with higher headquarters, while American forces always seemed to maintain perfect communication. We were fighting an enemy who controlled the battlefield through means we could, not counter." The SCR-300 was not solely responsible for German defeat, but it represented a technology that multiplied American advantages across every domain of warfare. Superior American industrial production meant more artillery and more ammunition. The radio ensured that firepower arrived where and when it was needed most. Superior American logistics kept artillery batteries supplied. The radio provided targeting information, making ammunition expenditure efficient rather than wasteful. Superior American training produced competent forward observers. The radio gave those observers tools to employ their skills effectively. April 1945. The final statistics. As German resistance collapsed and the war in Europe approached its end, Army analysts compiled operational data documenting the SCR-300's impact across the campaign. Over 50,000 SCR-300 radios had been delivered to units in the European theatre. Forward observers had called an estimated 2.3 million fire missions using portable radio communications. Average response time from initial contact to artillery fire on target measured 93 seconds, remarkably close to the original 90-second objective established in 1943. Casualty analysis provided the most compelling statistics. Infantry divisions, equipped with adequate SCR-300 radios and trained forward observers, suffered 25–30% fewer casualties during offensive operations compared to divisions with limited radio equipment or inadequate training. The correlation between radio availability and casualty rates was consistent across multiple divisions, terrain types, and operational conditions. Artillery ammunition expenditure showed similar patterns. Divisions with effective forward observer networks fired fewer rounds per enemy position neutralized, achieving better effects with less ammunition. The radio enabled precision that reduced waste and improved efficiency. One artillery battalion commander noted in his after-action report, "Pre-war doctrine assumed artillery would fire extensive preparations before infantry assaults, expending thousands of rounds to suppress defenders. Radio communications allow us to fire only when and where needed, responding to actual targets rather than predicted positions. We achieve better results with half the ammunition expenditure. The human dimension of these statistics emerged through soldier testimonies and unit histories. Infantry soldiers consistently credited forward observers with saving their lives through timely artillery support. Forward observers described the satisfaction of providing fire support that enabled infantry to accomplish missions with minimal casualties. Radio operators took pride in maintaining communications under the worst possible conditions, knowing their technical competence directly impacted soldier survival. Private Michael Torres, who had carried the SCR-300 for Lieutenant Chen from Louisiana training through the end of the war, summarized the radio's significance in simple terms during a post-war interview. That radio weighed 38 pounds. I carried it through France, Belgium, and Germany. My shoulders never stopped aching, but every time Lieutenant Chen called fire and shells hit exactly where he wanted, exactly when we needed them, I knew those 38 pounds were worth it. That radio brought soldiers home alive. You can't ask for more than that. The German perspective emerged through captured documents and prisoner interrogations. Wehrmacht tactical assessments from late 1944 and early 1945 consistently cited American artillery-infantry coordination as a decisive advantage. One captured operations order from February 1945 instructed German units. American infantry must be engaged at maximum range before they can establish radio communication with artillery. Once American artillery begins firing, withdraw immediately to prepared alternate positions. Do not attempt to maintain positions under American artillery. Fire. Preservation of force takes priority over holding ground. This order represented complete reversal of German defensive doctrine that had emphasized holding positions at all costs. The SCR-300 had forced German forces to abandon their established tactical principles because adherence to those principles resulted in unsustainable casualties when facing an enemy who could summon accurate artillery fire in 90 seconds. May 1945, Victory and Legacy. When Germany surrendered on the 8th of May 1945, the SCR-300 had proven itself as one of the war's most significant tactical innovations. The radio hadn't won the war alone. No single technology could claim that distinction, but it had fundamentally altered how American forces fought, reducing casualties while increasing combat effectiveness across every operation where it was employed. The post-war analysis extended beyond tactical success to institutional lessons about technology adoption. The SCR-300 program demonstrated that successful innovation required more than inventive technology. It demanded coordinated development of equipment, doctrine, training, and logistics. The radio worked because engineers designed it for combat conditions, because doctrine writers developed effective employment methods, because training programs taught soldiers to use it under fire, and because logisticians ensured adequate supplies of batteries and spare parts reached frontline units. The SCR-300 also revealed organizational adaptability within the U.S. Army. From initial concept to operational employment took 18 months, remarkably fast for military bureaucracy. The Army identified a capability gap, resourced a solution, tested the technology, trained thousands of soldiers, and integrated the new system into combat operations while simultaneously fighting a global war. This institutional flexibility enabled tactical innovation that gave American forces decisive advantages. The radio's influence extended far beyond World War II. Post-war military communications built on principles the SCR-300 established: portable equipment, FM transmission for interference resistance, standardized procedures, integration with fire support systems. Modern tactical radios trace their lineage directly to that 38-pound transceiver carried by soldiers through the fields of France and forests of Germany. The human legacy persisted through veterans who credited the radio with their survival. Reunions of artillery and infantry units featured ceremonies honoring forward observers and radio operators whose competence under fire had enabled responsive artillery support. The bond between infantry and artillery, strengthened through shared reliance on radio communications, became a defining characteristic of American military culture. Lieutenant Thomas Hawkins, who had carried the SCR-300 ashore on D-Day and across Europe through 11 months of combat, reflected on the radio's significance during a 1985 interview. "We started the first war using the same communication methods armies had used for centuries: runners, flags, telegraphs. We ended it with technology that seemed like science fiction compared to what we'd known before. The radio gave us power nobody had possessed before, the power to summon fire support instantly from anywhere on the battlefield. That power saved thousands of lives. The soldiers who came home owed their survival to many things: courage, training, leadership, luck, but also to 38 pounds of electronics that let us call artillery in 90 seconds. Germany never imagined portable radios would change warfare so completely. Neither did we, until we used them in combat and discovered what was possible. The question posed at the beginning had been answered definitively through combat testing across the most demanding conditions warfare could produce. Portable radio communications allowing infantry to call artillery in 90 seconds represented not merely an incremental improvement, but a revolutionary transformation of battlefield coordination. The Germans never developed an effective counter because no counter existed beyond avoiding contact or withdrawing when American artillery fire began. The asymmetry remained decisive through the war's end, contributing to Allied victory through thousands of small advantages accumulated across millions of soldier hours of combat operations. The SCR-300 weighed 38 pounds. Germany's inability to field equivalent technology cost them the war. That simple equation defined modern warfare's central truth. Communication speed determines combat effectiveness as decisively as firepower or mobility. The side that coordinates faster wins, regardless of other factors. 90 seconds proved fast enough to ensure victory. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.